Alright, here's my code for the 392 project. So first, just the imports. We use raster IO, NumPy, and Matplot. And then here's the file paths, just getting them into the Python file. And then right here is actually reading in the August bands, so just assigning them to values that we can use. Then here's the calculations for the NDVI and NDWI for the August rasters. So, of course, NDVI is near infrared minus red bands divided by near infrared plus red. And then NDWI is going to be green band minus near infrared divided by green band plus near infrared band. And also, that's just making sure you're not dividing by zero or anything. And then here's the plots for August. So this one is the NDVI, and we use red, yellow, green color map. And then this clears, and then NDWI we use the purple and blue color map. And then here's pretty much same code reading in December, same calculations, and then plotting, same color maps and everything. And then here's how we get our statistics. So this gives us the mean, median, standard deviation, and also just the valid pixels. Then just prints out everything we can see. I'll start running it just because it takes a second. And then here's calculates mean index values for the pixel, and then min and max so we can get our range. So if we look down here, we can see our mean, median, standard deviation, and valid pixels for all the values for August and December. And then here we also have the min and max range. So you can see everything's -1 to 1. And then here's also just the outputs for the map plots. So here's NDVI and NDWI for August. And then here it is for December.
NDVI calculation script. At the top, I imported Rasterio, NumPy, and Matplotlib. Then I set the file path for the NIR band and the red band here, all to the 392 lab projects. And I opened each band using rasterio.open and red band 1 as a float 64 array. Next, I calculated the NDVI using the formula here, which is NIR minus red divided by NIR plus red. After that, I visualized the NDVI using plt.imshow with the red, yellow, green color map. And then I added a color and then save the output as NDVI calculation, NDVI code output.png here. So when I run it down here in terminal, it will load here. And then it's creating the image file here. And then when I go into the file under projects, there's the NDVI code output.png here. It's just created. And then same for the NDWI. This is my NDWI script. I set the file path for green band and the NIR band. It read both as float 64 arrays. And then I calculated NDWI using this formula here. And then I display the result using the Pubu color map and save the figure as NDWI code output.png. And then when I also do the same thing in the terminal, it will load here and then it's creating the image file here. And then when I go into the project folder, there's the NDWI calculation, the pi, or it's this one that just created.
is for Sentinel-2 data. The data that we got from multispectral had 4 tiles, so we have to mosaic all 4 into one file. So here the code begins by collecting all the band 4, band 8 or whatever required rasters from the input folder. So after verifying that they were like present, it mosaics the band 4 raster. Band 4 you can see for band 3 and band 8 rasters into a single TIFF file by using ArcPy Mosaic to new raster management tool. So this ensures a clean, consistent dataset that can be used for downstream analysis, such as indices calculation. And down here, I also did a little bit of NDWI and NDVI computing for the September 2025 data.
Hi, my name is Mohammed, and today I'm going to be going through the classification section of the code of the project. So, as a basic rundown, we use k-means, which is an unsupervised classification machine learning method. And first, we processed the data, reprojected it, mosaic, pretty standard stuff, and then we normalized the data so that it could actually fit into the algorithm, and then we use k-means. We ran into some problems with the resolution because our project, our raster had millions of data sets points, and it was too big for my computer to run. So we had to go in chunk by chunk. So we would take in like 100 pixels at a time for memory efficiency. And this kind of led to a less high resolution output, but it was the most we could do with our resources. So this covers the Sierra Nevada mountain range, as you can see. This is k-means 5 classes. For example, just to go into the details, like the purple is the granite belt, green is healthy vegetation, red is burned vegetation, the black would be shadows or water in deep forest ranges. So yeah, that's the output of classification. K-means unclassified machine learning, and we went over this area. Unfortunately, it was rather difficult to get the other section of the forest, but it's covered most of the study area, so yeah.
The code is run in VS Code by cloning the ArcGIS environment. So this is the output for the mosaic raster that was created, and I have the boundary for the area of interest, that is Sierra National Forest. Let me turn that on. And from the NDVI calculation from the September 2025 data, that is after the wildfire occurs. So this is the NDVI that was created. So I also did a journal statistics from as table and got the values to look at the minimum, maximum, or like mean standard deviation values for NDVI. So in the same way, after running the NDWI calculation from the code, so this is the output for NDWI for the same data set.